Welcome back. Let's solve a problem using Brownie a few different ways, particularly the difficult get dx problem. Curve contracts generally have a get dy function, which tells you how many tokens you should expect out for a number of tokens put in. But most of these contracts don't have an equivalent get dx function, which would tell you how many tokens you need to put in to get a specific amount out. We're going to walk through a few different ways that Brownie can solve this. The simplest way is actually just the little known curve calculator. This is a contract that's been deployed to mainnet, and it comes built in with both a get dy and get dx function. So we'll be using this for one method, but there's a few different ways we can attack this. In this file I've created called get dx, we're going to walk through a few. In this file, we are pulling in a few different files, including one helper file I created called scripts.helpers.iter, which has a function to pull this amount iteratively. And the main function here is simply calling first the get dx function. You'll pass it a pool, a coin in and a coin out, and the dollars that you would like to get. We're going to make dx coin mintable so we can actually test the actual amount we get out of it. And the first way we're going to attack this is if you didn't know the calculator existed, you could attack it iteratively. So opening up this iterative file, what we're doing is we're going to first try and set bounds. That is, we'd like to figure out from a given value, let's get a value we know it's between under and over, and then we'll just take the average of that over and under iteratively until we solve it. So that's what's going on here in this while dx solved. It's running this loop, passing this min max value, and continue iterating unless we run into some issue where loops is greater than 100. And we run the loops, select our bounds. First up, we try and establish these min or max values, moving up and down by a value of 10x until we get there. Finally, when we have both the max and min set, we'll simply take the average and take a look and see if we go higher or lower, and return the values. The victory conditions for this loop, well, first off, we skip the loop if the min and max value aren't set. If they are set, then we'll run get dy, see if we nailed it. If so, then we'll return true. If not, we'll also look at the edge case where in some cases you might be moving with a token with a small number of decimal places with low resolution, and maybe moving it up by one of that token is going to launch it over. I'll leave this open because I'd like to run this print with the print statement just a minute. Outside the iterative estimate, well, then we just pass it to the calculator, see how that compares. And finally, we're going to take this value we get from the calculator. We're going to toss that in to actually run a fake exchange and see what the final balance actually is. So first, we'll just run this. This is on try pool. And when we run this, we're going to find out that this should get us very, very close within a way. And it's doing some work under the hood here and finds the iterative estimate, the calculated estimate, actually runs the transactions, and it finds out that in fact running the calculator value gets us within one way. If we want to see what's doing under the hood in this iterative method, it gets a little bit funkier. This is going to show us every single step of the iteration. You can see it gets to a pretty big number before it establishes bounds, and now it's just going back and forth between these numbers, trying to hone in on the exact amount until we get to this for iteration estimate. And if you look at that, the iteration estimate is very, very close to the calculated estimate. We notice these numbers are just a little bit different because we're going to a token with a smaller number of decimals. So there's a lot of values that could actually work to get there. And if you really, really care about extreme rounding precision, you could actually take a look and see which of these values gets you a little bit closer. So these are a few different ways to tackle this problem with Brownie. If you look through the get dy file, you'll also, the get dx file, you also find that we run the same where we look at the pool calculator estimates for the get dy function, giving you a few different ways you could tackle get dy. And if you just care about which parameters to pass into the calculator, from line 69 all the way through the end, we simply go through and return all the values that you can pass into that calculator function to get the correct answer. We hope this is helpful in solving the get dx question, multiple ways to attack it. All these files are in the GitHub. Feel free to reach out if you have any questions or comments. Thank you all.